Algebra 2, trigonometry, simplifying radicals. The expression radical 50 is equivalent to what? So you should have some experience at this level with radicals and square roots by now. So a lot of this is going to be recap of things that you've learned back in Algebra 1, and they're going to get more complicated as we move on through the lecture. But to start off with something simple like square root of 50 and how to simplify that. Now, by the way, right there, that terminology, sometimes we call it square root, sometimes we call it radical. In Algebra 2, in the next video, we are going to learn about higher power radicals like cubed root and fourth root and fifth root. And for those, it looks like the radical symbol, but you'll see a number in front of it like here. That would be cubed root. So this is a square root when there's no number. We could think of there being a 2 there, but we don't bother to write it, much like we don't bother to write exponents of 1 and coefficients of 1. So this is a square root of 50, and that's what you're familiar with. The way to reduce a square root is you need to think of two factors of 50, numbers that multiply to 50, but there are a few options. There's 5 and 10, 1 and 50, so on and so on. But you need one of the two of those factors to be a square number. And so 25 and 2 is our only option as far as factors of 50, and one of which being a square. 25 is the square in this scenario. So see how I'm writing this? I'm splitting it up into two square roots, square root of 25 and square root of 2. And the one that's the square, the 25, I'm putting that one on the left, and I'm circling it because that's the one that's going to be reduced. The square root of 25 is 5. The square root of 2 cannot be reduced, and so it stays the square root of 2, and 5 rad 2 is my answer. Now, the calculator, it's a pretty simple check. I don't have my calculator software on this computer right now, but if you type in the square root of 50, you're going to get some decimal, probably slightly over 7. But then you type in 5 rad 2, and you'll get that matching decimal, so you know you can do that. Now, if it is simplifying a radical with multiple choice, you could definitely guess and check with that manner. But like I said, they're going to get a little bit more complicated. That may not always be an option. Let's try another one, another basic one, 2 rad 45. The only difference here is we have a coefficient to the radical in this 2. And so that's going to stay there. And I'm going to split rad 45 into two radicals. And I got to find two numbers and multiply to 45, one of which being a square, and that would be 9 and 5. And again, I'm going to put the one that's a square on the left. 9 times 5 is 45, but the square root of 9 is 3. The square root of 5 is rad 5, cannot be reduced. And I bring down my coefficient of 2. Now that I have a 3 that came out of the square root and its existing coefficient of 2, they get multiplied to be 6 rad 5. And a quick check on my calculator of typing 6 rad 5 and 2 rad 45 will confirm that they are indeed equivalent. All right, so let's try something now that maybe you haven't done. This is radicals, but with variables and exponents. And basically, when it's an even number like this, it's pretty simple. Now, I mentioned earlier that square root, we can kind of pretend there's a little 2 right here. Well, all you have to do when you have a variable with an exponent is you divide the exponent by the root number. Divide exponent by root number. And so what that means, in this case, I'm looking at the square root of y to the 4th. My exponent is this 4. My root number is 2 because I'm doing square root. So if I divide 4 by 2, I get 2. So x cubed y squared. And that's essentially it for dealing with even exponents. They're very simple. You know, just another couple quick examples before we move on to the next problem here. Next to the, oh, having some airliner problems. Let me get that back. Like the square root of x to the 10th is x to the 5th. You're just dividing your exponent by the root number, in this case 2. Now everything we're doing in this lecture is square root, so you'll be dividing all your exponents by 2, but as I said in the next couple of lectures, you're going to see cubed root and fourth root and fifth root, and so that number you divide by will change depending on what power root we're dealing with. Okay, so let's look at one more example and end this video here. So simplify the square root of 100, a to the 16th, b to the 4th. Now this really is not a very challenging problem, because if I look at each of my pieces, they're considered square terms. The square root of 100, and this is a good tactic, what I'm doing right now is to separate it into pieces. The square root of 100, the square root of a to the 16th, and the square root of b to the 4th. So the square root of 100 is square. It is 10. And square root of a to the 16th, I'm going to divide by my root number of 2, is 8. And that's an important one right there, because a lot of people think it's going to be a to the 4th because we recognize that 16 as a square number. But when it's an exponent, it's just an exponent. It has nothing to do with it being square or not. It has to do with it being just an even number. 16 divided by 2 is 8. And then the square root of b to the 4th divided by my root number 2 is b squared. And so we're looking at 10, a to the 8th, b squared. When our exponents are odd, like say x to the 7th, that's slightly more challenging because I can't divide evenly by 2. What that means is I'm going to be left with 1 inside. And so I know this isn't the problem here, but I want to do this real quick on the video for you. So the square root of x to the 7th, just like how we split up something like 45 into 2 radicals, well, when our exponent's not even, you need to do the same thing. You need to split it up into 2 radicals, leaving 1 inside that one and 6 in this one. So if I split x to the 7th into x to the 6th and x to the 1st, I can now simplify the x to the 6th to be x to the 3rd, and x to the 1st stays in, so it's x cubed rad x. You could also kind of think of it as I am going to divide my 7 by 2, just like I divided my 16 by 2 and divided 4 by 2. But when I divide 7 by 2, the answer is 3, but there's a remainder of 1. And so that's what we're going to do with odd exponents. And we'll see that come up at some point during the class problems. All right, see you tomorrow.